Okay, here we go. Now I think people, if you're watching this on your from home, can you give me a thumbs up that you can hear this?
Yeah, we can hear you.
We can hear you.
Thank you. Hey, welcome everybody. It's nice to see you all. My name is, firstly, thank you for joining us tonight. My name is Victor. I'm a product marketer here at Detectify, and I'm going to go over some housekeeping in a moment, but I'm also to give you a bit of information about Detectify. I'm pretty sure I'm going to make a guess that most of you have some information about Detectify, but I'm going to just give you a bit of information about what we do. Should I?
Start with my slides.
Okay, yeah.
First.
Great.
Okay. Welcome everyone. I'm Naime. Also, actually, we work together with Victor, but I have two hats here today. I'm one of the OWASP Stockholm chapter leaders, and also in Detectify. And it's so nice to be here. I will just be doing a quick intro, and then we will switch to the talks. So thank you, Victor. Sorry, I think we didn't think about it before.
No worries.
Okay, so as you can see, we have Guillaume and Emre today as the speakers, and we are very excited. So let's not like delay. And also, hello everyone online. It's so nice to have some people also online listening to us. And just to give you a brief introduction of our team, we are 5 people in Stockholm, and you know, OWASP is a very big organization all around the world. And we are doing our best to do local events with these amazing people. And 3 of us are here today. Henrik is here, and Davis is there, and Akka and Shane are joining us online today. And we also have a volunteer today. Is Anastasia is here, and I just wanted to give a shout out to her because I think it's important that we have a small group, but also we are always open to you. Just come and join us and organize these events together. So give a, like just like a small applause. Oh, yeah. And today's agenda, you got some online applauses as well. So the agenda will be like we already gathered and mingled and started eating our pizzas. I hope online people are doing that too. So we will just have like a small introduction here, and we need to do some housekeeping rules. And the first speaker, then we will have a break. You can eat and drink more. And the second speaker will be here. Emre is here. Over there, and then we will have some like closure basically, and then you can be here until 9 p.m. I know it's always fun to hang around, so enjoy it, and we will be also around. So I'll just give to Victor very quickly, and thank you all for coming. I'll speak to you later.
Guillaume, Naime said I have 5 minutes, so I'll hand it over to you in that 5 minutes. Hey everybody, this is Detectify. We are a company based here, obviously here in Stockholm. We also have a presence in the US. We have some customers and we've been mentioned a bit, but that's boring information. What I want to talk to you about is what Detectify does. The first thing we do for the primary problem that we solve for our customers is that we help them find vulnerabilities in their applications. And that's not terribly unique. There's a lot of companies that help with that. And one of the challenges our customers have is that the first problem is they have a lot of vulnerabilities. That's a challenge. It's very stressful for their teams. A lot of those times those vulnerabilities have poor signals, so they might be false positive prone. We also know that our customers have challenges with maintaining their internal security requirements. And lastly, one other challenge they have is that it's difficult to manage so many tools. And we help our customers with this challenge. And one of the ways that we do that is by looking at their entire attack surface. A lot of companies will go and put a ton of domains and say, hey, we found these domains for you. But at Detectify, we go a little bit further. We are then going to actually start fingerprinting technology on those domains. And if we see something, in this case of this Git configuration file, we're then going to send a payload. And that's important because many vendors today actually will just fingerprint something and then say, hey, Linda, because I remember meeting you outside, we found a vulnerability on this GitHub configuration file. You should go check it out. We're actually going to send a payload, and when that payload resolves on that asset, we're then going to say, hey, we found something that a hacker could hack. And that's what how Detectify approaches it. We'll skip that slide. This is our product. We have our crowdsourced community of ethical hackers who are finding vulnerabilities, often things that are going beyond CVEs, like 0 days, for example. And our new AI security researcher, Alfred, which I'll talk about in a moment, that we just released. We do a lot of discovery and recon on our customers' attack surface. We do different types of testing kind of across their entire attack surface, but then we do like crawling and fuzzing on those applications that they build, and we obviously put it into their integrations. But let's talk a little bit more about crowdsource. This is the community that we've had for quite a long time, and these are hackers literally all over the world. They send vulnerabilities to us. We look at those. If they make sense for our customers, we then build a module or build a test for our customers and put that right into our product. And that's how it's worked for a very, very long time. Now we have this tool called Alfred, and Alfred is going to go out into the world. He is going to, or they, or it is going to find vulnerabilities, in this case, CVEs. It's then going to find a CVE, find a proof of concept for it, and then build a test that our team, some folks actually here on that team, review it, and then actually put it into our product. So if we go one step deeper, it then gathers intel autonomously. It's looking at a bunch of different sources. There's a person here at Detectify who can probably tell you more about that. And then ranks those vulnerabilities or those POCs that it finds based off EPSS, builds a test for it, our team reviews it, and then it goes right out into our customers. And it does it pretty fast. I think this week we've had a few tests developed by it and shipped to our customers. Last week we had 24 that it found online, and then we shipped to our customers. So we're pretty excited about this new feature. All right, I'm 1 minute left. So housekeeping. The bathroom is to the left, right out here. The emergency exits, we have one there, and then we have one that I let you all in today. And then there is food and drinks on that corner. Did I miss anything? All right. I think I did in 4 minutes. All right, here you go, Naime. Thank you, everybody.
I think I'll stop sharing at this stage and give it to Guillaume, and maybe we can also welcome him. He's from GitGuardian, and I'm really excited about Scapy because we have heard so much about it. And actually, Frederick, one of our security researchers, he told us a little bit, but I want to hear from Guillaume. So if you're here, you can just unmute and maybe we can leave it to you, Guillaume. Welcome.
Thank you. Do you see my screen?
Yes, we do.
Okay, perfect. So as you just said, I'm working for GitGuardian. So it's not the purpose of the talk today, but we are a French-based company that is doing secret detection in not only source codes, though GitHub, GitLab, many other things like Jira, Confluence, Docker. And that will be it for the presentation of the company. If you want to play around, we have an open source tool that you can use. I will put the link in the chat if I can find it here. That's just a tool that you can use to scan for secrets in files, GitHub, and whatever data source you want. So you can install it really easily. And today I'm here to talk about a project that I'm working on with other people, which is Scapy. Maybe you know it. It's a tool that turned 22 in March, a few days ago. That's really old Python project. And my goal today is to give you a quick tour of the main features. So the link is in the chat, and then I will try to follow the content. So briefly, Scapy, that's a library, Python library, Python tool that helps you to manipulate packets really easily. So it's 22 years old, sorry. It was developed by Philippe. We then turned the maintenance to Pierre and me in 2012. Since a few years, we are joined by other maintainers. We have Gabriel and Niels from Germany. That's the only non-French maintainer of the project. And we are trying to make Scapy still be able to work natively on Linux, macOS, and BSD. It also works on Windows. It's not really native because you need to install the npcap.dll. It's required because we need to have some let's say, Windows drivers and also some library in userland to be able to send and receive packets on the network. You can get the tool directly from GitHub. On GitHub, you will also find a bunch of demo documentation. Here you have the same slides that I'm presenting in a shorter way. So hopefully you have everything you need online. If you want to play today with Scapy without installing it, you can go to the scapy.net website, and you can click on, let me check, here. You can click here, try Scapy, and then we'll give you a kind of a shell that's basically Scapy running in your web browser, and you can type everything you want. That's pure Python. So if you're a bit lazy, you can just use that today. Don't need to install anything, don't need to trash your laptop or whatever at the end of the day. The only limitation, obviously, that you won't be able to send and receive packets on the network because the Python process is in your web browser. So briefly, in project status, we moved from Bitbucket to GitHub 9 years ago. It was a great move from the project because we managed to get more and more contributors. We managed to get the CI for free. So we're using a lot of GitHub Actions and other CI provided by the GitHub ecosystem, and that helps us to be sure that the project works perfectly on Linux, macOS, and Windows. And then when we introduce changes, that we not break anything. We do our best to maintain also Scapy on OpenBSD, FreeBSD, and NetBSD. From time to time it breaks. So OpenBSD is really important because Scapy is used in OpenBSD to test the IPv6 stack. So if we break OpenBSD support, it will break the CI for OpenBSD. So we have a huge task to tackle. And also moving from Bitbucket to GitHub allowed us to have a better code coverage. So when we started this move, I think the coverage was 50%. Nowadays it should be 90. It's also really important because it makes the project more stable. And a few years ago, almost 8 years ago, we decided to move from Python 2 to Python 3. And having a good code coverage really helped us to make sure that when we did a change and a tweak from Python 2 to Python 3, the code was still working. So if you want to install and play with Scapy, what you can do is just clone the project, git clone, and the github.com link, and then you go into the Scapy directory and you just run Scapy script as the root user. So you don't really need to do that. Again, if you don't use the super user admin root on Linux, you won't be able to send and receive packets on the network. So that's up to you. So what we'll do today, we'll go from the basics of Scapy and then go a bit deeper in things you could do with IPv6 and TLS. If you have any question, you can ask them in the chat, and I will try to give you some answers. Slides, you have them. So packets manipulation. So in Scapy, packets are Python objects, which means you need to use the parentheses if you want to create an object. So in that example, we'll put, let me check the annotation. We'll put TCP on top of IP, and to do that, we'll use the slash operator. So this one is usually it's used to divide numbers. In Scapy, it's used to stack and push and put protocols on top of each other. And then we assign that in the packet variable. And then because everything is objects, what we can do, we can put packets on top of Ethernet. And then if you do that in Scapy or in Python shell, that will be the output. Scapy will say, okay, your object contains TCP on top of IP on top of Ethernet. And then you can see some elements. Scapy automatically managed to see that you want to put IPv4 on top of Ethernet, and he put the type to IPv4. And it did the same for TCP. You want to put TCP on top of IP, so it will put the TCP value in the protocol field here. Next, if you don't know what to do with a packet, what you could do, you could use ls IP, and Scapy will list the name of the field. So for example, if you want to specify destination address, it will be here DST. If you want to change the TTL, it will be here TTL. And I will show you how to do that in the next slide. On the right side, you have the default value. So IPv4, the version is 4, TTL is 64, and then you have known. Known means you want Scapy to compute the value for you, which is in the case of a checksum really interesting because you will be able to put, for example, DNS, UDP, and IP, and Scapy will compute the checksum. You don't need to actually do it yourself and give it the correct values. We clean that again. And next slide. Okay, so here we know what to do with the IP layer, and we decided to put the secdev.org value in DST, and we will put the fin flag into the flags field of TCP. We put everything on top of Ethernet, assign that to the P variable, and then call the summary method on it. Scapy will return a string in Python that is a compact representation of what we want to do. We want to send TCP segment to port 80, that's the default port for TCP, to the destination, which is secdev.org. Later on, we'll see how we can actually send this object to the network. But we managed to build this simple network packet. With Scapy, you can access the fields really easily. So if you do pdst, that will give you the first layer with a DST field. In that example, the first one is the Ethernet destination address. If you want to display the IP destination source address, you need to be explicit about it and say P, and then use the square brackets, put the layer you want to access, .src, and that will print the source address of the IP layer. As you recall from the previous slide, we didn't specify any SRC, which means that Scapy internally is able to do it for you. It will basically load its own routing table. It will load all of the interfaces, and it will be able to match the destination address using a specific entry in your routing table and your source address of the correct interface. We have many different methods. This one, sprintf, is used to use format strings specific to Scapy to display values. So here what we do, we want to display the Ethernet source address, the Ethernet destination address, and then on the next line, we'll print the source address of IP and the destination of the IP packet. And that's the display on my laptop. Next, a field can store a single value, like an IP address, a port, a flag, but it can also store many values. So in that example, we'll ask Scapy to make the TTL value be from 1 to 5. So the value will be TTL 1, 2, 3, 4, 5. If you don't know this weird line, maybe you don't know Python, that's basically a loop that will iterate over all of the possible value. So we say for each packet in this specific Scapy packet, please print them or please access them. So here we have 5 different objects with the TTL changing from 1 to 5. So that here the parentheses that you need to use. That's a sequence of value. So if you want to specify specific values, you need to use square brackets, which is a list in Python. So here we want to specify the SSH port, HTTP port, and HTTPS port. So that's 3 different packets. The one will be destination port SSH, HTTP, and HTTPS. So it's a really convenient way if you want to send a bunch of packets, do a network scan, for example. There's some different protocol values, so it's kind of a packet template. Next, I need to clean that. Next, what if you want to actually send packets on the network? Let's have a look. First, we have the SR1 function, which means send and receive one. Send and receive one packet. So here we'll send a DNS query to the Google public DNS server. So we'll put DNS on top of UDP, on top of IP. Destination will be 8888. SR1 takes one packet, send it, and waits for answers on the network. And if it finds one answer, it will give it back to you. So the answer will be stored in P. So here we have display of what Scapy is doing. Just say, I will start to send. I finish to send one. I receive 9 packets in the time frame that I'm sniffing, and I got one answer. And the answer is the following. So that's P, a DNS answer. So here we'll go directly into the DNS layer, and then we'll print the answer, which is stored in the AN field. The answer is the following. It's called a DNS resource record, and Scapy did the decoding for you. The question, or indeed the response, is www.example.com, which means that automatically in DNS, here we ask what is the IP before address of www.example.com. In that example, and when I did the tests, it was this IP address. So it's really simple, and again, Scapy is giving you a lot of default values that will work in most cases. Next, what if you want to send many packets at the same time and also wait for the corresponding answers? In that case, we use SRP. Something that is a bit weird in the IP of Scapy, because Scapy is old. If you look at that, we have SR1, which means send and receive. Indeed, it means send and receive at layer 3. So send and receive at the IP layer. You have SRP or SRP1, which means send and receive at the layer 2 layer. So SRP is on it. So here we do pretty much the same. We put DNS on top of IP. And here, because SR is able to send and receive multiple packets, we'll ask to do some kind of trace route. And we'll make the TTL value change from 5 to 10. So 5, 6, 7, 8, 9, and 10. We'll send 6 packets, and hopefully we'll receive 6 answers. We put this IP payload on top of Ethernet, and then we use SRP. SRP, that's a function that returns 2 variables. One is called R, or we can name it received, but on the slide, R is more compact, and U will be unanswered. So R is a list of queries you sent and the match answers, and they are stored that way. And U is just a list of packets without any answers. So here that the display, R is of type results, specific Scapy Python object, and the type is result, and the other one is answered. But it's basically a list with a bit of different display. So we'll have a look at R and see what is inside these answers. So if you want to access the first packet you sent, you need to go into R0. R0, 0, which means we take the first tuple of query and answer, and then R0 will be the first query, and 1 will be the first answer. Then what we'll do next here, we'll just check what is the content of the first answer. Here that the first query, and here that the first answer. And then we can move into the packet and check the content of the ICMP layer. We can see that we got a TTL time exceeded ICMP error message. And inside we have a copy of the full IP header. And that's how traceroute works. When your message reaches the first router, and not the first router, so in that example, that's the router after 5 hops, the TTL will be decreased to 0. So the router will send you an error message, that this one, and that error message will contain a copy of the message that actually triggered the error. And we can see that it received the message with TTL equal 1. So when it decreases the value, it will turn to 0. And that's why we receive the message time exceeded. And we can learn here that at the fifth hop, the value of the IP address of the router, that's this one. Okay, so that's basically digging into how threshold works, and you can easily do that with Scapy. You can also with Scapy easily write a pcap file and read from a pcap file. So the function is wrpcap, and you just give a file name and a list of packets you want to store. Since 2 or 3 years, we also support pcap-ng. Next generation, the format is a bit different. And for example, you can put some comments in Wireshark or comments in Scapy. You can exchange the packets and some metadata like comments, TLS keys, and to be able to decrypt the messages. And you can put that in pcap-ng. In that case, you need to use wrpcap-ng in order to use a new format. To read pcap, there is nothing to do between the two formats because Scapy will detect that for you. You can just use read pcap, rd pcap, and the name of the file. And then Scapy will give you back a list. And if you want to check the first element in the list, that's a message with TTL5, so that's the one from the previous slide. So here, that's a message sent to Google Public DNS Server with TTL equals 5. We have a DNS payload, and here we have the question, which is, what is the IPv4 address, the type A of www.example.com. That's a copy of what we sent. That's really useful if you want, for example, to save these packets and open it in Scapy later, or if you want to actually use this packet in Wireshark, send it to someone else. That's really convenient. If you want to fuzz the packet, for example, it could be a good way to start. Comment, that's interesting. Comment, if you call it on an object, it will give you a string that you can copy and paste. And the string is the exact copy of the Python object. So it's a way to, let's say, serialize easily a Scapy object, and also for you a way to copy that in a script, change some values, and actually send what you exactly want to send. So it could be used in some kind of attacks when you know the specific packet will trigger a vulnerability, but you don't want to put all of the fields in your Python script. You just sniff this message, copy it in Python, modify the values, and send it again with the correct target, for example. Sniff is a bit like TCP dump or T-Shark. So it's used to capture packets on a network. So here we'll use it to sniff 2 packets. We'll use the count2 argument. So sniff count2 in S, we have a list. In the list, we have 2 elements. In that case, Scapy give you a nice display. We have 2 TCP segments. What we can do next is use a callback on the sniff function. So every time a packet will be received, what we'll do, we'll display a short version, summary, that we have seen before. So again, if you're not familiar with Python, this basically means please call a function every time you receive a packet, and this function will return the summary of the packet. So every time we have a Scapy object, we will call p summary, so summary on the packet, and return the answer. That's just, again, for the slide, a compact way to not define a function, but still be able to call a function on each packet. In Scapy, we have many different commands that are available as a user. And if you want to list them, you can use lsc, so list commands. Some of them are used to do ARP ping, so you will ping using ARP protocol. You can do cache poisoning, you can do DNS resolution, you can do a fake DHCP server, you can fake also some IPv6 services, auto advertisement, for example. You also have a bunch of things already implemented for you. DHCP request, and so on. So the first function we'll have a look at is ARP-ping. So ARP-ping will, in that case, take my network, send ARP request to all of these IP addresses. So 256 packets are sent. And here in my network, we only receive 2 answers. And here we have the MAC addresses and the IP addresses corresponding to these answers. If you have some specific database that match the first 3 bytes to a network vendor, and this database come easily with the Wireshark, Scapy will, in the middle here, display the name of the vendor. Could be Cisco, could be Juniper, could be Apple, and so on. It's also really interesting if you have devices at home, internet object, your TV, and you are looking for the specific IP address and you don't know it. You can use ARP-ping, and then we'll give you the name of the manufacturer. Help could be useful. We are not really good at documentation and help, but from time to time, help really helps. So if you call help on traceroute, it will give you the different values, arguments that you can actually set in the function to make it work. So let's have a look at traceroute, but from the visualization point of view. Sorry, did I miss something? No, traceroute will be a bit later. So visualization. So this slide is a bit tricky, so I won't describe it in detail, but here the goal is to say that if you are able to use Scapy in a Juniper notebook, and I did this slide with a Juniper notebook, you will be able to get some values and do some plots. And in that example, the answer variable, which was named R before, we can call multiplot. So we have embedded ways in Scapy to take some values from the packet and display them. So in that example, we'll display the IP ID, IP identifier for these two different IP addresses. We have the str function. So indeed, since a few release, this is not correct. And that's for me a way to say that from time to time, the documents, stuff you find on Stack Overflow is not fine. So here you need to use row. str was for the Python 2 version, and row is used in the Python 3 and the version that we have that does the Python 2 and Python 3 compatibility. And if you call row on the packet, Scapy will give you back the let me check if I can move that. You can row on the packet. Scapy will actually return the binary representation of the packet. That's the same thing that Scapy will send on the network. So it will take the object, compute all of the values, TTL, checksum, source address, ports, and so on, and give you an answer. So here we have in the binary representation of the DNS query we want to send to a destination. Wait, sorry. Xdump, that's also really convenient. We'll give you X representation of your packet. So that's still the IPv4 header. So here we can see it starts with 45, so it means that it's really highly likely an IPv4 packet. And then later on, we can see that we have example.com, which is actually the question we want to ask to the DNS server. Show will give you the contents of the packet layer by layer. You can see that some packets are not computed for you. The internet header length is still known, the value is known, len is known. Same here for checksum. If you want to compute, Scapy to compute the value, you can just ask and use show2, and show2 will give you the correct values every time you have none here. So it will basically take the object, construct the object in binary, and then decode it again. Oops, I need to close that. Not really convenient. This function, dump, canvas dump, is giving you another representation. Could be useful in reports or if you do some protocol analysis. Basically, it will map a view like show to the binary representation of xdump and show you that 45 means version and internet header length. And then we can follow the 35 here, which are the source port and destination port values. Traceroute, that's a convenient way to replace SR or SRP as we did before. So here the traceroute will be to secdev.org. We'll say, I want you to stop after TTL 15. You can also use min TTL if you know that if you need to do a traceroute in your network and you know there is several hops before reaching the internet, you can just say min TTL equal 5 or 6, and then Scapy will start the traceroute at 6 or 5. So here that the result of traceroutes. And then we can do many different things on that. And one of the things we could do is display the traceroute on a world map. That's really, really fun. So basically, we are using GeoIP database to map an IP to a GPS coordinates, and we do the display. So the result is more or less accurate, precise, but it's really nice when you need to do traceroute and see if the packets are actually going from one country, one department, one state to another. Make tables, another visualization. Here again, I won't go into the details, but basically it helps you to have your own really compact representation of packets. So here, what we'll do, we'll send different probes to host, scanme.nmap.org and nmap.org. We'll probe on TCP and on UDP, and then we'll ask Scapy with make table to do a nice table. So here, the value for the column will be the IP address, and here for each packet we'll do the row. So the row name will be the either TCP port, UDP or UDP port, and then the value will be the value of the TCP flag or the ICMP message. And what we can see here for port 22, port 22 SSH is open on both destination, and HTTPS is only open on one of the two hosts. So it could be also a good way to do a quick network scan and compare the results, things that it's a bit more difficult to do in one line with the Nmap, for example. So Scapy has a Python module, so it's based on Python, and you can use Scapy really easily in your own tooling. It's heavily used for POC, so this year it was used for a proof of concept for an RC on the PlayStation 4. It's often used as a tool to do a proof of concept for Wi-Fi vulnerabilities. So we are used as tools to perform attacks. So there's almost nothing to do if you want to use Scapy in your own tool. First, you will import Scapy from Scapy all import star, and then you are able to use everything like in Scapy shell. So the following line that just to have a nice, let's say, command line parsing, that's basically boilerplate. And here that's a bit of one ugly one-liner where we will in one go build an ICMPv6 echo request message that a ping will send it to a destination and then give you the answer. That's ping 6 in one line in Scapy. So that's a bit fast and short to fit on the slides because we are not checking for any errors, but just to give you the power of Scapy, in few lines you're able to build your own custom network tool. And for example, you can decide that you want to do the same ping 6 with a specific payload or change the up limit, the TTL value in IPv6. You can also implement your own protocol. So I'm going a bit deeper, let's say in Scapy things that you can do. So just what you need to do and to understand if you want to implement your own layer with Scapy, you need to build an object. So here it's DNS TCP. You need to inherit from packets, and then you need to define a list of fields. And here we have two types. The first one is a short, and the other one is a list of packets. So basically, we'll take a value. Let's call it, let's give it a size like 12, and then we'll decall 12 bytes as a DNS header. That's a bit specific, but it's good to know that you can do your own stuff. So here, what we have, we'll create a DNS TCP layer, the one we just created. With row, we'll convert it into bytes, and then DNS TCP will decode the bytes. So here we have len 12, and then an empty DNS layer. Stream sockets. Again, good thing to know. I will be quick. Will not detail the slides, but from time to time, you don't want Scapy to do the TCP processing. You want the operating system kernel to do it for you. So in that case, what you will do, you will open a socket with the socket module in Python, and then you will give the socket to Scapy and ask Scapy to send and receive at the TCP layer using the kernel. Answering machines. So far, Scapy, what we have seen today, that we are sending one message, we are waiting for one answer. Answering machine, that's the opposite. We'll wait for something, wait for one packet, and send back an answer. So you have several things you want to do for an answering machine. The first one is to create an object. Again, we are doing Python. So that's here. You need to inherit from answering machine. And then you need to define two methods. The first one is a request. Just say true or false. So here we check, do we have a probe request in packets? So probe requests, that's messages that are sent by your devices, like my phone, to look for access points on all of the channels. So you will connect to channel 6, send a probe request, wait for a probe answer, and that's how you will have the display on your phone, on your laptop, of all of the available access points. Then you need to define make reply. Basically, if this one said yes, we'll send a reply. So the reply here will fake an access point called Scapy, and that's it. So that's a bit of too deep to discuss basically how you will build .11 probe response with Scapy with all of these really important .11 elements. That's not really relevant for today's presentation. Anyway, if you have Wi-Fi chipset, which is able to inject packet, raw packets, usually it's called monitor mode on Linux. And if you launch your phone, you will see the following. You will see that there is a fake Wi-Fi access point called Scapy. If you click on it, obviously nothing will happen because that's the only part of the Wi-Fi protocol that we implemented here in the answering machine. But still, some people are using that to play some jokes and display some funny names in conferences or in meeting rooms. So IPv6, that's also a big feature of Scapy. That's the only tool that allows you to play with IPv6 message that precisely. So here we are sending a router solicitation message. Scapy takes care of everything. If you send this message on a network with IPv6, you will likely get an answer. So here we are asking for the router on the network. We have an answer which is called router advertisement, and inside we have many useful information. The first one is the prefix to use on the network. This one is a public prefix. If you configure your addresses, or indeed if your kernel is configuring addresses on this prefix, you will be able to communicate on the internet. And then the router is also giving the IP address of the DNS server to use. This one is on your local network. What you could do next, you can probe for node nodes and the list of manufacturers. In that example, it didn't work because I didn't have the database of the manufacturers loaded. But here we'll send an SCMPv6 echo request message to a specific IPv6 address, which is called FFO2::1, which means everyone in my local network. So when I did the test, I had like 4 IPv6 nodes connected on the network. Trying to hurry a bit because that's almost the end of my my slots. Certificate manipulation. So X509, that's the name of the certificate type we use with TLS. So with Scapy, we have a way to manipulate these packets. So you can use certs and load the certificate. So cert GitHub, that the GitHub certificate I use for the demo. You have method that you can call on the certificate. Is it self-signed? False. Can you give me the subject? And you can also check if the packet, the certificate is still valid and how long will it be valid for. In that example, the value was 245. You could, if you know the certificate authority and you load it in Scapy, you can check if the issuer of GitHub was DigiCert. The answer is true. You can do other trick. For example, you can change the signature. So here I will put the value 42 in X. I assign it to the serial number of the GitHub certificate. I will load a private key, so my own private key, and I will re-sign the certificate. Here I will display the values that I just changed in the certificate and verify the signature. So obviously this new certificate here is not valid anymore because I changed the signature, so it's not valid with the DigiCert signature. But it's a cool trick that shows you how easy it is with Scapy to manipulate certificates. And I know that when I was doing some penetration testing with IoT devices, I had to use this trick to actually change the certificate on a device, change the signature, and that way we're able to do some man in the middle. That's a good trick to know. Other things you can do with Scapy, you can use TLS. You need to load the TLS layer. You can just sniff easily and then look for client hello messages. So here we have client hello with TLS 1.2, and Scapy will decode everything. I'm over for today. So if you have any question, let me know. We have more to discuss in Scapy. That's a short presentation. We have automaton. That's a way to create state machines easily, so that how we implemented TCP. And we have other, let's say, advanced features like pipes, where you can sniff a packet, send it to a file, read it in a pickup, do some processing, and then send it back. So if you have any questions, let me know. If you like the project, please go on GitHub and start it, send issues, pull requests. And yeah, thank you for your time.
Thank you so much, Guillaume. And I just want to ask the people here if anyone has questions you would like to ask to him right now, or maybe I think they want to reach out later, maybe, but
Twitter is fine. The chat is good.
okay.
Everything is fine.
Okay, I think I didn't check the chat, but are there any questions there?
No.
Okay. Then thank you so much, and we really appreciate having you here online. Maybe one day we'll just meet in person.
Hopefully one day I will be able to travel. My friend said that Stockholm is a really beautiful city. So next time, hopefully, I will be with you.
Actually, it's a really beautiful city, and would like to see you there. Maybe in summer. Just start with summer. Okay. Thank you so much, Guillaume, and yeah, we'll speak
Thank you.
later.
I'll stay online. I will shut down my camera, but I will still be listening.
Okay, of course. And we'll just have a short break now for the people who are sitting here for 40 minutes. So let's just stretch our legs and get some drinks and prepare for the next presentation then. Thank you, everyone.
Bye-bye.